We want to find the Laplace transform, which is big F of s, of the function f of t equals 3. Looking at the definition below, suppose that f of t is a piecewise continuous function for t greater than or equal to 0. The Laplace transform of f of t is equal to the integral from 0 to infinity of f of t times e raised to the power of negative st dt, where s is greater than 0. So for this example, f of s is equal to the Laplace transform of 3, which equals the integral from 0 to infinity of 3 times e raised to the power of negative st dt. Now, because we have an improper integral, we need to rewrite this using limit notation. So for a quick review, looking at case 1, the integral from a to infinity of f of x dx equals the limit as b approaches infinity of the integral from a to b of f of x dx. So notice how we substitute b for infinity and then introduce this limit notation. So this is equal to the limit as b approaches infinity of the integral from 0 to b of 3 times e raised to the power of negative st dt. Now for our next step, let's go ahead and find the antiderivative of 3 times e raised to the power of negative st dt. Then we'll come back and evaluate this definite integral and then find the limit. So let's first find the integral of 3 times e raised to the power of negative st dt. Notice how we need to perform u substitution, where we'd have u equal negative st, and differential u is equal to the derivative of negative st with respect to t times dt, which would be negative s dt. Dividing both sides by negative s, we can write this as negative 1 divided by s du equals dt. So in terms of u, we can rewrite this as the integral. Again, dt is equal to negative 1 divided by s, so we can write this as negative 3 divided by s du, and this would just be e to the u. So the antiderivative is just negative 3 divided by s e to the u plus c, but u is negative st, so we have negative 3 divided by s e to the negative st plus c. But remember, we had a definite integral, so going back to our first slide, we have the limit as b approaches infinity of, again, this is a definite integral, so we can leave off the plus c, and the antiderivative is negative 3 divided by s e to the negative st. Our limits of integration are from t equals 0 to t equals b. So now for our next step, we'll find big F of b minus big F of a, and then we'll determine this limit. So when t equals b, we'd have negative 3 divided by s times e raised to the power of negative sb, minus, when t is 0, we'd have negative 3 divided by s times e raised to the power of negative s times 0. Simplifying, we have the limit as b approaches infinity of, for this first term, let's write this using a positive exponent by moving e raised to the power of negative sb down to the denominator. So we'd have negative 3 divided by s times e raised to the power of positive sb. And then here, e to the 0 is equal to 1, so we have minus negative 3 divided by s, which becomes plus 3 divided by s. And now determining this limit, remember s is greater than 0, so as b approaches infinity, the exponent on e approaches infinity, and therefore the exponent is increasing without bound, and the numerator is fixed at negative 3, so this term approaches 0. This term is not affected by b, and therefore the limit is equal to 3 divided by s, which is the Laplace transform of f of t equals 3. So to summarize, the Laplace transform of 3 equals big F of s, which we now know equals 3 divided by s. So going back to our first slide, of course we enter 3 divided by s. Now I do want to mention, after we do several examples, we'll stop using the limit definition to determine Laplace transforms, similar to how when we first found derivatives, we used the limit definitions, but then we started using a table of derivatives. And just like there's a table of derivatives, there's also a table of Laplace transforms. And here are a few formulas for basic Laplace transforms. Looking at this first row, if we have f of t equals 1, the Laplace transform is big F of s equals 1 divided by s. Notice how because we had f of t equals 3, we multiply 1 over s by 3, we get the Laplace transform of the constant function f of t equals 3. So for each example, after we use the limit definition to find the Laplace transform, we'll also look for the corresponding formula in the Laplace transform table. I hope you found this helpful.